Now, within the permanent table space, we have two types of table spaces again. One is just the table space, regular table space. The second is undo table space. So to store undo data, we'll have another type of table space called as undo table space. So these are the different types of table spaces what we have in Oracle. So whether it can be a big file table space or a small file table space. Irrespective of big file or small file, we have permanent table space and temporary table space. And within the permanent table space, we have regular table space and undo table space. And then we also have temporary table space. Temporary table space is used to store temporary data. Undo table space is used to store previous values or the accurate values to provide read consistency, and this is used to store the regular data. And you already know the difference between a big file table space and small file table space. Big file will have only one file and the maximum amount of size it can be is 128 terabytes. Whereas small file table space will have one or more data files, and each data file with a block size of 8 KB, the maximum size you can create will be 32 GB. Next, we'll see how to create a table space. But before trying to create a table space, we have to know what are the different options available while we create a table space. So we already saw whenever we are trying to insert data into the table, space will be allocated in terms of extents rather than the exact size of the data you are inputting into the database. So it will be allocated in terms of extents. So what will be the size of extents which will be allocated for the table? If you are inserting a row into the table which is of, say for example, let us say it is 512 bytes, but even though you are inserting 512 bytes of information, 8 KB of extent will be allocated. Why 8 KB of extent is allocated? So while creating the table space itself, you will specify what should be the size of the extent. And also whenever Oracle is trying to allocate an extent for a segment, extents will be allocated for the segment. So whenever Oracle is trying to allocate an extent for a segment, whenever it is trying to allocate an extent for a segment, it actually stores information. So I mean, like, what are the extents which are available in order to allocate it for a table? So what are the extents? What is the address of the extent? How many extents are free? How many extents have been already used? So all that information, the information about the extent allocation, how many extents are free and how many extents are allocated for the segment, is you can, in Oracle, you can store it in system table space. We already saw what is a system table space. So the extent allocation, we can either store it in system table space or we can store it locally into the table space itself. What information? About the extent allocation information. How many extents are allocated for a segment and how many extents are free, all those information. Either you can store it in system table space or you can store it in locally table space. Locally means with respect to the table space. If you have 5 table spaces, in that table space itself, you will store the information about extent allocation. Now, if you want to store the extent allocation information in a system table space, that table space is called as a dictionary managed table space. Dictionary managed table space. If you want to store the extent allocation information in a system table space, it is called as a dictionary managed table space. If you want to store extent allocation information in the locally table space itself, it is called as a locally managed table space. Okay, again the table space can be classified into dictionary managed table space or locally managed table space. So this can be distinguished based upon how you want to store the extent allocation information. Now, till 9i, this is the only approach we have, storing the extent allocation information system table space. But starting from 10G, we have both the options, system table space or locally managed table space. And Oracle recommends to use locally managed tablespace. And almost, I mean, like 99% of the companies will be using locally managed tablespace because there are lot of advantages with locally managed tablespace compared to the dictionary managed tablespace. The reason is we already know the system tablespace information. What does a system tablespace contains? What information does system tablespace contains? System tablespace contains metadata information. All the dictionary views like db underscore users, db underscore tables, db underscore segments, all those data dictionary views will be present in the system tablespace. So system tablespace is nothing but it contains metadata information. Okay.
Yeah.
So every time you are trying to access an object, in order to get the address of the object, it needs to access a system table space in order to get the address of the object. And also, whenever you are trying to access an object, you should have the privilege to access that object. Even that privilege information will be stored in system table space. Okay. So each time you are trying to access an object, it needs to access the system table space a lot of times in order to get metadata information. Now, within the same table space, if you are storing the extend allocation information also, then this table space will become a hot object. That means every time you are accessing an object, it needs to access system table space. As a result, you will face input-output contention because I mean, like each hard disk will have one input-output controller. Each hard disk will have one input-output controller. This is the one which actually writes the content into the hard disk. So one input-output controller can only serve one request at a time. Now, as if you want to store the external allocation information also in system table space, this input-output controller needs to do a lot of work. So instead of that, distributing the work among the different table spaces by storing the extended allocation information locally to that table space itself will avoid the hot block contention or the input output contention, because if you have two table spaces and one table space which is system table space, let us say it is present in slash database, the user table space, the second table space is called as user table space, and it is present in another mount point called as U01. As a result, you will have two input-output controllers instead of one, and your request will be served in a faster way when compared to having external allocation information in the system table space itself. Okay, so blindly you can say why dictionary managed table space is not preferred is to avoid input-output contention, as system table space is already a hot object, as it is frequently used by the Oracle to get all the metadata information. It is better to avoid storing extended allocation information in the system table space. So that is the reason why Oracle recommends to use locally managed table space. Okay. So while creating the table space itself, you need to mention whether you want to create a locally managed table space, whether you want to store extended allocation information in local table space itself or in the system table space. After that, what should be the size of extent? So whenever an extent is allocated to the table, what should be its size? So to determine the extent size while creating the table space, you have two options. To specify the extent size, Oracle provides two options. One is uniform, the other one is auto allocate. Uniform means you have to specify the size, for example 5 MB or 8 KB. So whenever you specify uniform whenever you're creating a table space with uniform extent size of 8 KB. That means every time an extent is allocated for a table, it will be allocated in terms of 8 KB. Or else you can also go for auto allocate. Auto allocate based upon how much of data you are inserting into the table. It will decide the extent size. Both options have advantages as well as disadvantages. Coming to uniform extent size. For example, right now you are inserting 10 rows. That is fine with 8 KB extent. For example, if you are inserting 1000 rows, in that case, you may need 100 extents allocated to the table. That means it needs to allocate 100 extents. Oracle needs to allocate 100 extents. So it will take a lot of time in allocating the extents itself. So your insert will be slower. If you go for an auto allocate, it will predict in such a way that your insertions will be faster. Instead of allocating 8 KB extent, it will be allocate initially. For example, if you are trying to insert 10 rows, it will allocate 8 KB only. But if you want to insert 1 million rows or 1000 records, based upon the size, it will automatically increase the extent size. So if you know, for example, if you know the size of each row is uniform in a table, then it's better to go for extent size with uniform option. If you don't know the size of the row in a table which you are going to insert, in that case it is better to go for auto allocate option. In most of the cases we use auto allocate option rather than uniform option. Okay, so while creating the table space, first thing what should come into your mind is extent allocation information, where you want to store it. After that, you want to know how the extents should be allocated. Then, how the segments should be managed. I'll tell you how what is the segment management. If this is a table and you're allocating 8 KB extent to this table, think you're allocating 8 KB extent. No, let me change it from 8 KB. For example, you are allocating 64 KB extent. Okay. Now, you already know each block is of 8 KB, correct? That means 8 blocks will be allocated for this segment. This is EMP table, and if Oracle needs to allocate one extent, and it is allocating 64 KB of extent size. Now, each Oracle block will be of 8 KB. That means it is actually allocating 8 blocks. Am I correct or not?
Yeah.
So 8 blocks of each 8 KB will be allocated for this segment. Altogether, this is called as an extent. Now, when you are trying to insert a row, for example, this is EMP table and you are trying to insert Mohan into that table. Mohan is the employee name and employee number is 10. So probably it may require 1, 2, 3, 4, 5 bytes plus additional 4 bytes, for example. So it requires 9 bytes. Okay. Now, which block needs to be used in order to store these 9 bytes? So within this extent, you already know what is an extent. It's a contiguous blocks, collection of contiguous blocks, correct?
Yeah.
So for example, this block size address is 100. This will be 101 and this will be 108. Usually the first block will be used whenever you are trying to insert the row.
Okay.
The first block in the extent. Now, out of this 8 KB, each is 8 KB, correct?
Yeah.
Now you are inserting one row and it is occupied 9 bytes. In a similar way, you are inserting 1000 rows. And as a result, the first block is filled. Now, you need to insert 100 more rows. Next, available block will be allocated for this segment. But this will not be the case. You may think that it will be allocating the blocks in this way, but it is not like that. Because the problem with this approach is, now if I want to update, for example, the 1000 rows which I inserted into this block, all the employees are located in New York. Okay, so I'm also inserting a row into the EMP table in such a way that I'm also specifying the location, and all the employees which I inserted into that block are New York employees. Now, instead of storing the location in a shortcut form NY, I want to store it in a full form New York. What should I do in order to update that information from NY to New York?
Just update.
Yeah, so we need to issue the update command. So I'll do update EMP set location equal to New York where location equal to NY.
Yeah.
Now, if this block is totally used for 1000 rows, that means 8 KB of this block is totally used. Can I update NY to New York within this block?
No.
Because NY requires 2 bytes, whereas New York requires, including space, it requires 1, 2, 3, 4, 8 bytes.
Yeah.
8 bytes. So it cannot allocate sufficient space within this block. As a result, you need to use another block in order to store the New York column. I mean the location column. Correct or not? So if you do that, that means another block will be used in order to store the location as New York. As a result, whenever you are trying to get the information from the table, it needs to access 2 blocks. That means you are increasing the physical input output. In order to avoid this problem, in order to allow some space within the block for the future updations, while creating the table, we will specify how much of space should be left within this block for the future updations. So while creating the table itself, we'll specify. So one of the parameter which we use while creating the table will be create table emp ename varchar2 of 10 emp number of 5. After that, we'll specify PCT free space 10. That means whenever you specify PCT free as 10, in each block 10% of the block size will be left free, such that whenever you are updating in the future, that reserved space will be used for the future updations. Okay, PCT free is one of the storage parameter you specify whenever you are creating a table, and the amount of space you will be left free in, the amount of space left free in the block will be used for the future updations. Okay. అర్థమైందా?
యా, అర్థమైంది.
No.
10% కూడా సరిపోకపోతే ఏమవుతుంది?
యా, అది ప్రాబ్లం కదా. 10% కదా సరిపోకపోతే అది ప్రాబ్లం.
ఓకే.
బట్ అంటే యూజువల్గా అయితే నువ్వు డిసైడ్ చేస్తావు అనమాట ముందే, అంటే ఫ్యూచర్లో అప్డేషన్స్ ఎలా అవుతాయి దాని ప్రకారం పీసీటీ ఫ్రీని డిసైడ్ చేస్తాం.
ఓకే.
ఇన్ ఏ సిమిలర్ వే పీసీటీ ఫ్రీ ఏమో ఫ్యూచర్ అప్డేషన్స్ కోసం బాగానే ఉంది. నౌ ఐఎమ్ డిసైడింగ్ టు డిలీట్ సమ్ ఆఫ్ ద రోస్ from this table. So I'll delete 500 rows from this block. I have 1000 rows in this block. Now I'm decided to delete 500 rows from this block. Okay. As a result, 3 KB free space is present in this block. Apart from the 0.8 KB which is reserved for the PCT, which is reserved for the future updations. We also have 3 KB of more free space because of the deletion. Okay. Now, can this block be used for the future insertions? Now, if I'm trying to insert 500 rows, should Oracle allocate the third block, which is the next available block, or it should allocate the existing free space which is present in the first block?
If you want to specify anything, it will allocate this in next block, right?
No, I'll tell you. So whenever an extent is allocated for a table, it actually maintains a free list. Free list is nothing but a linked list representation. Okay. So it will store the address of each and every block. So present ga first initial extent allocate చేసినప్పుడు అన్ని blocks free గా ఉంటాయి. So that means in the free list you will have the 8 blocks addresses starting from 100 to 108.
Okay.
Now when the first block is filled, when you insert 1000 rows and the 1000 rows occupied 7.2 KB of space in this block, that means 0.8 KB is left free because of the PCT increase for the future updations. The moment the total amount of space used in this block reaches 7.2 KB, this block will be removed from the linked list. Next, if you are inserting 100 more rows, then the next available block address in the linked list will be 101. As a result, 101 block will be allocated. Okay.
Okay.
Now, even if the amount of space left in this block reaches 0.8 KB, that means 7.2 KB is used. Even this block will be removed from the linked list. Now, at this moment of time, I will delete 500 rows from this block. So when I delete 500 rows from this block, whether this block address should again come back to linked list or not. That means whether it should come back to free list or not. So that depends upon another storage parameter called as PCT used. Whether a block can be present in a free list. That means whether a block can be used for inserting data or not depends upon the PCT used parameter. Okay. And this also comes into picture after the future deletions, because initially the block will be having free space and it will be present in the free list. But once it is removed from the free list, after that, if you delete some rows, whether that block should come into the free list or not, it depends upon PCT used value. For example, if you specify PCT used as 40, that means whenever the used space in the block falls below 40%, then this block can be added to free list. సో మీరు 500 rows డిలీట్ చేసిన 3 KB స్పేస్ వచ్చింది కాబట్టి 3 KB is not 3 KB ఫ్రీ స్పేస్ వచ్చిందంటే 3 KB ఫ్రీ స్పేస్ వచ్చిందంటే 3.8 పోయితే 4.2 KB యూజ్డ్ ఉంది కదండి ఇంకా 4.2 KB means it is more than 50%.
Okay.
So still this block will not be added to the free list. Whenever you delete 300 more rows, whenever it goes below 4 KB or 3.5 KB, 40% of 8 KB means 3.2 KB. So when it goes below 3.2 KB, then only this block can be added into the free list. అర్థమైందండి?
Yeah.
ఒక్కటి అది ఇప్పుడు యూజ్ ఉంది కదా, అది మన పీసీటీ ఫ్రీని కన్సిడర్ చేస్తుందా? దాన్ని కన్సిడర్ చేసి ఇది 40% తీసుకుంటుందా, లేకపోతే అది చేయకుండా 40%?
అది కన్సిడర్ చేసి తీసుకుంటారు.
ఓకే. అంటే మీరు ఇప్పుడు ఇంతకుముందు ఎగ్జాంపుల్ 10% అనుకున్నాం కదా,
లేదు సారీ పాయింట్ 8 పక్కన పెట్టేసి పాయింట్ 8 కాకుండా మిగతా అమౌంట్ లో 40%.
అదే అంటే 7.2 40.
యా.
ఓకే.
So now while creating the table space, you can specify whether this segment management should be auto or manual. This specifying PCT free and PCT use is nothing but segment space management. And now how you want to go for segment space management? If you want to go for auto segment space management, you don't need to worry about specifying PCT free and PCT used. Oracle will take care of it. Depending upon your usage, it will decide the PCT free and PCT used. If you go for a manual segment space management, in this case, you need to specify PCT free and PCT used every time you create a table. Okay? Either you can let Oracle decide about the segment space management, or you manually can decide the segment space management. In most of the cases, starting from 10G, we'll use auto segment space management.
Okay.
And whenever you're using a manual segment space management, in that case only, you will have the free list representation. If you go for an auto segment space management, in that case, you will have some bitmap patterns. Oracle internally it does. You don't need to worry about that. But just you have to know that whenever you're going for auto segment space management, it will have, like whether the block is free or not, it will decide based upon the bitmap pattern. If you go for a manual segment space management, it will depend upon the free list, whether the free list has an entry for that block or not.
Okay.
So these are the things you need to know whenever you are creating a table space. Now I'll show you how to create a table space. Create table space. Table space name. Data file. You already know table space contains data files, one or more data files. So you have to specify the data file location. After that, data file location. Then you have to specify the size. So let's say I want to create a data file of 1 GB. After the size, you have to specify the extent management. So in order to store extent management information, extent allocation information locally to the table space, you'll specify extent management local. The moment I specify the extent management local, extent allocation information will be stored in this table space. rather than storing it in the system table space. After that, I will specify auto or uniform. So this will be the extent size. Whenever an extent is allocated for the table, what should be the extent size? So either you can go for auto or uniform. If I want to go for auto, I'll just specify auto. If I want to go for uniform, I'll specify uniform, and then I have to specify the size. For example, 64 KB or 5 MB. I'll just specify your size. Okay.
Okay.
After that, we'll specify the segment space management. Auto or manual. If we specify segment space management manual, then while creating the table, you have to specify PCT free and PCT used.
Okay.
This is how we'll create a table space. Now, the same statement, if you want to create a temporary table space, this is a statement to create a permanent table space. Okay. Now, if you want to create a temporary table space, we'll just add temporary keyword to the command, and instead of data file, we will have temp file, because to store temporary information we use temp files. Then, if you want to create an undo table space, instead of temporary, we'll use undo table space. That's it. And this will be data file only, because permanent data file will be used for undo as well as for the permanent data. Okay. Now, the initial size you created is 1 GB table space. If that table space size is not sufficient, because in an hour this 1 GB gets filled, in a real time in an hour this 1 GB gets filled. So in that case, you need to continuously monitor the size, how much of free space is left in the table space, and then you need to keep on increasing the table space size. If you don't want to keep on monitoring the table space usage, and if you don't want to keep on adding or resizing the table space size, you can specify a feature called as, after specifying the size, you can specify auto extend on next 10 MB, max size 31 or 32 G. So you already know, in a small file table space, by default, whenever you're creating a table space, by default a small file table space will be created. Okay. So in a small file table space, the data file max size will be 32 GB. Now, so whenever you specify auto extend on next 10 MB, that means whenever there is no free space left in this table space, Oracle automatically resizes this data file from 1 GB to 1.1 GB, or if I specify auto extend on next 100 MB, that means it will resize the file from 1 GB to 1.1 GB. Once it reaches 1.1 GB, it again increments by 100 MB more. As a result, the data file size will be 1.2 GB. It will grow till 32 GB size.
Okay.
Now, even if this 32 GB is not sufficient, in that case, you have to add the data file. You need to monitor the table space usage, and then you need to add one more data file to the table space. So to add one more data file to the table space, the command will be alter table space, the table space name, add data file location. So yeah, after that size. For example, even for this, I can specify 1 GB and then auto extend on next 100 M, max size 32 GB. In this way, I can add data file. Okay. Or else, if I specify the max size as 12 GB, and if it reaches 12 GB, then I will have two options. Either I can resize the existing data file size, or I can add one more data file. So whenever you want to increase the table space size, you have two options. One is you can increase the size of existing data file, or else you can add one more additional data file. If you want to change the existing table space size, you have to alter the data file size. To do that, the command will be alter database data file location resize, and then you'll specify the new size. So I'll specify 17 GB. So these are the two options available in order to increase the table space size. Okay.
Yeah.
Now, if you want to create a big file table space, the command will be similar. Just you need to add one more keyword. Create big file. That's it. The rest of the command will be same. Instead of max specifying 12 GB, you can just specify unlimited. Even with small file space, even with small file table space, you can specify max size as unlimited, but it can grow till 32 GB, not more than that.
Okay. Next, I mean, alter table space, add data file. Do we need to mention for that also, like extend management, local auto, or something?
No. The extend management and segment space management is applicable for the table space level.
Okay.
So you don't
So
need to
for data
specify.
file, no need.
No.
Okay. Yeah. Here we are just adding the data file. Right?
Yeah. Next. If you want to delete a data file from the table space, for example, I created a table space with 3 data files. So while creating the table space itself, instead of specifying one data file, you can specify 3 data files. So that you can do that by using size 1 GB, auto extend on, max is unlimited. After that, you can specify comma, and then you can specify data file clause again. You can specify the second data file name or second data file location, and then you can specify the size of the second data file also.
Okay.
Now, I created a table space with 2 data files. Now I'm thinking that I don't want 2 data files in that table space. Just one is efficient. One is sufficient, which is of 32 GB. The user doesn't require any more additional space. In that case, I have to drop a data file from the table space. To drop a data file from the table space, we'll use the command alter table space name, drop data file location.
Okay.
In a similar way, the resize option which I told you, you can either increase the size or you can shrink the size. But whenever you are trying to shrink the size, you need to make sure the amount of space you are shrinking is free. If the amount of free space available in the table space is 1 GB, amount of free space in the table space is 1 GB, and if you want to resize or if you want to shrink it by more than 1 GB, you'll get an error saying that it is already been used, you cannot shrink it.
Okay.
Now, by default, a table space will be in read-write mode. That means this table space can be used for performing input-output operations. You can also place a table space in read-only mode. That means only read-only operations can be performed. You cannot perform write operations. So you cannot do insert or update. So if you want to put a table space in read-only mode, you'll use the option alter table space name, read-only. This will make the table space read-only, and as a result only users can access the data but they cannot modify the data. This will be used whenever we require any downtime or whenever if we want to do any modifications on the tables. We'll make the table space read only, or we'll make the table space read only and we'll make the changes on the backend. Or else you can also have the option to put a table space in offline mode. So whenever you put a table space in offline mode, this table space you cannot access it. That means you cannot also do the select statement. Putting a table space in read only will allow you read only access, but if you put a table space in offline, it cannot be accessed. The objects in the table space cannot be accessed. In a similar way, within a table space, if you have 4 data files and only one data file has the content related to the application you want to modify, in that case you can put one data file in offline or read-only mode. Instead of specifying the whole table space, by putting that whole table space in offline or read-only, it will the rest of the application will also require the downtime. But here, if only one data file is used for that respected application, then you can just put one data file in read-only mode. In order to do that, the command will be alter data file name read-only or offline. So you can also put a data file in read-only or offline mode. Again, if you want to put back in read-write mode, instead of read-only, we'll use read-write. If you want to put the table space back in online instead of offline, we'll use online. Okay?
Yeah.
Now, whenever you're creating a table, if I log in as Scott user and I create a table, where this table is stored, where this table is created. So it will depend upon the default table space of a user. So every user will have a default table space. In a similar way, Scott have a default table space as users or example. As a result, whenever you're creating a table, it will be stored in users table space or example table space, because the default table space for the Scott is users or example. In a similar way, whenever you're creating a temporary table, even in this case, it depends upon the default temporary table used for a user. This you'll know actually whenever you're creating a user. I'll show you in the user management how to specify the default table space. But just remember, whenever you're creating a table, by default it will go to a default table space of that specific user. If you're creating a permanent table, it will go to a default table space. If you're creating a temporary table, it will go to a default temporary table space. Okay? Now, the undo. Undo is specific to the user. Undo is not specific to the user. It is specific to the database. So, at any time, only one undo table space can be used to store read consistent data. So you'll know the undo table space, the default undo table space at the database level by using the command show parameter undo. This will give you the default undo table space. So let me log into the database, show parameter undo. So this is my undo table space. So undo TBS1 will be used to store read consistent values. Even I create another undo table space. Create undo table space undo TBS2 data file slash database slash test undo TBS2 underscore 1.dbf. It's better to follow this naming convention. On table space name underscore data file number. As is the first data file number, I'll specify it with underscore 1. It will be great if you go with underscore 01, because a table space may have 30 or 40 data files also, depending upon the volume of data you'll store in the database. 10 MB. You can just go like this. If I create a table space without specifying extend management and segment space management, by default it will go for extend management local and segment space management auto. Please remember, if I don't specify any extend management clause and segment space management, by default it will take extend management local and segment space management auto.
Mohan, one question, small question, like how many data files we can add per a table space? Is there any limit?
There is no limit, but there is a limit actually. I'll show you what is that limit. Show parameter files. Okay, so if you see here, the total number of data files I can have for the database is 200 data files.
Okay.
This is at the database level. So maximum I can have is 200. But this parameter you can modify it. I can do just alter system set db underscore files equal to 300. Let us see what happens. Just I can modify it. And this will be affected after my reboot. Okay.
Okay.
So it will first, it will depend upon db underscore files parameter.
Okay.
But you can increase that db underscore files parameter. But until what value you can increase, that actually depends upon the block size, operating system, whether it's a 32-bit operating system or a 64-bit operating system. Depending upon that, the value will be given. Usually if you do Google, you'll get the answer. I don't remember the exact values, but depending upon the type of operating system and type of Oracle block size, this number of data files will be determined.
Okay.
So if you have just one table space, you can create up to 300 data files within that.
Okay.
Now, if you see here, I created the undo table space, but this undo table space, undo TBS2 will not be used until I change this parameter. So if I decided to use undo TBS2, I need to alter the parameter undo underscore table space to undo TBS2. So at any time, only one undo table space will be used to store the read consistent data. But whereas temporary table space or a permanent table space, it will depend upon on which table space you want to store the temporary table, on which table space you want to store the permanent data. So Squad user itself, if two temporary table spaces are available in the database, Squad user can create one temporary table in one temporary table space and another temporary table in another temporary table space. So if you want to create a table in other than default table space, as I already told you, by default it will depend upon the default table space whenever you create a table. If you decided not to create a table on a default table space, in that case, while creating the table itself, you have to specify the table space clause. That will specify it using table space table space name. So if I decide if I want to store this EMB table in a table space called as Mohan, I'll specify the table space as Mohan. So instead of creating this table space, instead of creating this table in a default table space, it will create the table in Mohan table space. Okay. Next, we already know undo table space will be used to provide read consistency. This is one of the main advantage of undo table space. Not only that, undo table space will also be used to perform rollback operations. So for example, if you are updating 1000 rows, after that you decided the modifications which you are done are not correct. In that case, you haven't issued the commit yet, right? So you can do a rollback. I already showed it to you how to do a rollback. So we can just issue rollback. So this will roll back all the changes you made. But how does it actually performs the rollback? It uses the undo table space data in order to rewrite the updated content. Okay. So these are the two main advantages of using undo table space. One is to provide read consistency. The other one is to perform rollback operations. Undo table space will be used. Next is temporary table space. We already saw this will be used to create temporary tables. But not only that, there is one more advantage of creating a temporary table space. So whenever your query has order by or group by, it requires some memory. If you remember, which memory component will be used to perform sorting operations?
PGA.
Yeah.
I mean,
Yeah, PGA
yeah.
will be used for performing the sort
Sorting
operations.
Yeah.
But for example, the amount of PGA allocated for a server process is 30 MB, and you are retrieving 1000 MB of information from a table, and you are performing sorting. In that case, you may require additional space. 30 MB will not be sufficient. So whatever the additional space it requires to perform the sorting operations, it will take it from temporary table space.
Okay.
So the additional space which needs to be used to perform the sort operations, that additional space will be taken from temporary table space. So apart from storing temporary tables, it will also be used to perform sorting operations. Okay.
Okay.
Not only that, whenever you are trying to create an index on a specific column, it actually creates an index by sorting the values, because it needs to know what value is greater, how it should organize into a B tree. As I said, B tree is the default index, which whenever you create an index, a B tree index will be created, and it will be organized in the form of a binary tree. So first it needs to sort the column values in order to create the index. So as part of creating the index also, it will use the temporary table space. Okay?
Okay.
ఇవన్నీ చూపిమంటారా లేకపోతే మీరు ప్రాక్టీస్ చేస్తారా?
ఏమండి ఇదే?
అంటే మామూలుగా టేబుల్ స్పేస్ క్రియేట్ చేయడము, యాడ్ చేయడం డేటా ఫైల్ని.
అవి మేము చేస్తామండి.
యా. Next thing is we already saw how to drop a data file from the existing table space. Now if you want to drop the table space itself, in order to drop the table space itself, the command will be drop table space name including contents and data files. So you can just specify drop table space name, this will only drop the definition, but it will not remove the data files from the physical locations. If you want to remove the data files from the physical locations also, you have to specify this command, including contents and data files. So including contents means it will drop the tables which are present under in that table space. So first it will drop the objects, after that it will remove the data files. So we already saw how to check the table space usage. So the table space usage, you can get it by joining db underscore data underscore files and db underscore free underscore space. But this will give you the usage of permanent table space itself. Default permanent table space. Take it as default permanent table space. If you want to know the usage of undo table space or temporary table space, there's a different way in order to see the undo table space usage and temporary table space usage. The reason for that is, for example, if you have a temporary table space, within this temporary table space you have one data file which is called as temp1.dbf, and the size of this temp file is 10 GB. And if you are doing a select statement from EMP order by ename, for example, and this sort statement requires 200 MB of sorts, 200 MB of sort area, and the PG allocated for this user or for this server process is, say for example, 100 MB. So the additional 100 MB will be used for this from this 10 GB, correct?
Yeah.
Now once this statement is completed, once user performs another statement, it will not clear up the space. The space will be cleared whenever there is no free space left in the temporary table space. Until then the 100 MB will be still be showing as used. So that is the reason why you don't you should not join db underscore data files and db underscore free space. You need to use some additional views in order to get temporary table space usage and undo table space usage. In order to get a temporary table space usage, you need to join two tables. One is $sort underscore usage and $session. By joining these two views, you'll get the amount of temporary table space usage. How much of space is being used right now by all the sessions. And if you want to know the under usage, you need to join $V transaction. And $V session. This will give you the under usage. Do you want me to continue or do you want me to wind up?
Yeah. I think it's sufficient for today.
Yeah. So class రేపు తీసుకోనా ఫ్రైడే రోజు తీసుకోనా?
నాకు థర్స్డే ఎగ్జామ్ ఉంది మోన్.
యా ఫ్రైడే తీసుకోవాలా మరి క్లాస్?
ప్లీజ్ అంటే శివాకు కూడా ఓకే అయితే నాకేం లేదు.
Yeah, that's fine. నాకేం ప్రాబ్లం లేదు.
మీకు కూడా ప్రాక్టీస్ చేయడానికి టైం ఉంటుంది కదా. యా ఓకే దెన్.
ఫ్రైడే సేమ్ టైం కదండి?
యా ఫ్రైడే 8 PM.
ఓకే.
ఓకే.
యా ఓకే దెన్ బాయ్.
థ్యాంక్స్ అండి.
బాయ్.